Here's another question about the order of things and things being sort of put in a place to wait for a minute. When people enter a line for a service, like at a fast food restaurant, for example, entering at the back and being served at the front, what is always true of the person currently being served? So if I have some people lining up for a new iPhone or a hamburger or whatever, and one person lines up, another lines up behind them, another lines up behind them, another behind them, and so on. When a person gets served, for example, this person gets served at the front, what's true of them? What's true of this person? What's true of this person when they're served? And again, we'll probably want to think of ordering or sort of what features might be true. And we may also want to consider circumstances where more people join as other people are being served. But what will be true of that person who is currently being served? So again, I'd encourage you, even if you've got an idea, sort of half formulating, to just pause for a moment, as in pause the video, and think through your answer and try to think through as many features as you can about this structure we're building and the person that would be served. What's true of them? What can we guarantee? So pause, think it through for a moment. And one thing that you may have come to notice about the person being served is the line built up behind them full of people who arrived after them. So the person who gets served will always be the person who arrived earliest, or another way to frame that is the person who's been waiting the longest. So it will be the person who arrived earliest. The very first person that will be served is the first person who arrived in the line. The second person will be the second person who had arrived in the line, or the person who was second earliest in the line, and so on and so on. So the person who arrived earliest will always be the one who is served currently of the ones who are remaining. And so we get an order that is first in, first out. Whoever was first into the line, the queue, is the first one out of that line. So this is the idea around which we'll build the data structure of a queue, which differs from a stack. A stack was last in, first out, and the queue will be first in, first out. One thing that you may have also noticed in that example of the people getting served in the line or the queue is that even if new people joined in the middle, it didn't disturb the ordering in which people were going to be served. So unlike the stack where new things pile on top and we might end up popping off one of the things and then piling some stuff that fills the space that it was in, here things will always be added in the back. So if I were to put in the numbers 1, 2, 3, 4 into a queue, I will get out the numbers 1, 2, 3, 4 in that order because I will be adding things at the back and getting things from the front. You may also start to make a connection that there may be another data structure that we've talked about in the past that has this feature of the back and front to it that might be useful in our thinking about how a queue can work. And so for a queue, unlike the stack which has push and pop, we often have, again, two operations that are absolutely required, adding and removing. If you want to be fancy, there are other words that people will sometimes use for these. They are NQ and DQ. These are a little too fancy for me, so I like just add and remove. but we put something into the queue and we remove something from the queue. And those are our two main operations. We might again have a peek type of operation where we can look at what's at the front of the queue, what would come out next. This is not strictly required for the queue to work, but it can be helpful to not have to edit the queue to be able to look at what's in there. And to give you an example of something that a queue might be used for, they're used all over the place in computers for buffers. When you, for instance, input a command at the command line, you want to make sure that the output from the first command that was run is the first output that comes out, so the user can associate those with each other. And if they run a second and a third and a fourth command, they should get that output in that order. The second command's output second, the third command's output third, and so on. So if you have to hold on to information, but you do want to make sure that it comes out in the order that it was given, and comes out in that order even if new commands are added while the other ones are running, then a queue can be very helpful for this. So it gives a strict in-order behavior to it, and you'll get a little more of a chance to look into that as you work at the activity sections C, D, and E.